P substrate is produced through the doping process. It is used as the base layer for building devices. Processing is carried out and a thin wafer cut from a single crystal of silicon of high purity into which the required P impurities are introduced as crystal is grown. Such wafers are typically 75 to 150 mm in diameters and 0.4 mm thick and are doped with, say, boron to impurity concentration of 10 power of 15 per cubic to 10 power of 16 per cubic, giving resistivity in the approximate range 25 ohm centimeter to 2 ohm centimeter.
SiO2 layer thick oxide. A layer of silicon dioxide SiO2, typically 1 ohm thick, is growing all over the surface of the wafer to protect the surface. Act as a barrel to the pans during processing and provide a general insulating substrate onto which other layer may be to deposit and plating. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Saya Samsuar bin Opong. The surface is now covered with a photoresist which is deposited in onto the wafer and spun to achieve an even distribution of the required thickness.
Okay, next. The photoresist layer is exposed to ultraviolet light through a mask which defines this region into which this process is to take place together with transistor channel. Assume, for example, that choose area is exposed to ultraviolet radiation polymesis, but that the area required for this question shielded by the mask and remain unaffected.
These areas are subsequently readily etched away together with the underlayer silicon dioxide so that the wafer surface is exposed in the windows defined by the mask. Thank you.
P substrate. P substrate a polysilicon layer, CiO2 thin oxide, CiO2 thick oxide. The remaining photoresist is removed and thin layer of CiO2 is 0.1 micron typical. It is grown over the entry chip surface and then polysilicon is deposited on top of this to form the gate structure. The polysilicon layer consists of a heavily doped polysilicon deposited by chemical vapor deposition (CVD). In the fabrication of fine pattern device, precise control of thickness, impurity, concentration, and resistivity is necessary.
Further photoresist coating and masking allows the polysilicon to be patterned, and then the thin oxide is removed to expose areas into which n-type impurities are to be diffused to form the source and drain as shown. Diffusion is achieved by heating the wafer to a high temperature and passing a gas containing the desired n-type impurity, for example phosphorus, over the surface as indicated in figure 1 to 8. Note that the polysilicon with underlying thin oxide and the thick oxide act as masks during this fusion. The process is self-aligning. Thank you.
Thick silicon oxide is grown all overall again, and is then masked with the photoresist and etched to expose selected area of the polysilicon gate and the drain source area where connection, example contact cut, are to be made. A metal as aluminum layer of 1 micrometer thickness is deposited on the entire surface by the CVD process. The metal layer is the pattern with the help of a mask and the photolithographic process. Necessary interconnection are provided with the help of this metal layer.
We'll explain about summary of CMOS process. First mask, pattern SiO2 to expose the silicon surface in area where patched in the different layer of source. Mask 2, pattern the ion implantation which in the Tixnox region where depletion mode device are to be produced. Mask 3, deposit polysilicon overall. 10 pattern using mask 3. Using the same mask, remove thin over layer where it is not converted by polysilicon. Mask 4, grow thin oxide overall and 10 each for contact cuts. Mask 5, deposit metal and pattern with mask 5. And the last mask would be requirement for the overglassing process. Thank you.